Keep moving, lads. Not far now. Hold him steady. Morphine now. Careful! Get him inside! Hold steady, we're nearly there! Generators up, sterilization next. The culture is thickening. Good, that means the yield is up. We must maintain these conditions.
January 1943. North Africa. A line of trucks crawls through the dust toward a cluster of canvas tents just beyond the front. Inside the first tent, lantern light flickers against white sheets already stained dark with blood. The air smells of antiseptic, sweat, and desert sand carried in on boots and stretchers. Surgeons stand over folding tables. Their sleeves are rolled. Their hands move quickly, but the line of wounded outside keeps growing. The war has changed. These soldiers are not suffering the slow wounds of trench warfare. They arrive torn by artillery fragments, burned by exploding fuel, crushed by tanks, and shattered by high-velocity bullets. Some are carried and unconscious. Others whisper for water. Many simply bleed. The medical system meant to save them was designed for a different war. In the First World War, wounded men often waited hours, sometimes days, before reaching real surgery. Infection killed almost as many soldiers as bullets. Medicine could follow the battlefield, but it could not keep up with it. Now, in World War II, mechanized armies are moving faster than doctors ever imagined. And unless medicine changes with them, thousands more will die long before the battle is over. The realization is spreading quietly through the U.S. Army Medical Corps. Modern war is forcing a medical revolution. Before that revolution could begin, however, the United States had to confront the reality of the system it brought into the war. To understand why the Second World War transformed military health care, it is necessary to look back at the system that existed before the war began. When American forces entered the global conflict in 1941, the structure of battlefield medicine still carried the imprint of an earlier era, the First World War. During that conflict, from 1914 to 1918, medical systems were built around a very specific type of fighting: static trench warfare. Front lines barely moved. Armies fought from dugouts and trenches separated by narrow stretches of devastated land known as no man's land. When soldiers were wounded, the process of evacuation followed a slow and rigid path. First came the regimental aid post, usually a shallow dugout or sandbag shelter where a medic could stop bleeding, bandage wounds, and give morphine. From there, wounded soldiers were carried by stretcher bearers across muddy trenches to a dressing station, often several hundred yards behind the front. The journey could take hours. Under artillery fire, it sometimes took much longer. If the soldier survived the trip, he might then be moved by horse-drawn ambulance or truck to a casualty clearing station, where surgeons could attempt more serious operations. Finally, after another long journey by rail or convoy, the wounded reached large hospitals far behind the lines. The system worked slowly, but it had been designed for a battlefield that barely moved. The Second World War would be very different. But the deeper problem in early 20th century battlefield medicine was not speed. It was infection. Antibiotics did not yet exist. Doctors understood how bacteria caused infection, and they attempted to clean wounds using antiseptics like iodine or carbolic acid. But once bacteria entered deep tissue, medicine had few reliable ways to stop it. Shrapnel wounds were especially dangerous. Metal fragments often carried dirt, clothing fibers, and bacteria deep into muscle. Even a small wound could become fatal days later as infection spread through the body. One of the most feared complications was gas gangrene, a rapidly spreading bacterial infection that destroyed tissue and released toxins into the bloodstream. In many cases, the only treatment was amputation. Even then, survival was uncertain. Statistics from World War I revealed a grim truth. Roughly 1 out of every 3 wounded soldiers who died did so from infection, not from the initial injury. For military doctors studying the problem between the wars, the lesson was clear. Speed mattered. The faster surgeons could clean and operate on wounds, the better the chances of survival. By the late 1930s, some improvements had begun to appear. One of the most important was the development of blood transfusion techniques. During World War I, transfusions were often performed directly from donor to patient, limiting their usefulness on the battlefield. But new research had discovered ways to store and transport blood using anticoagulants and refrigeration. Another breakthrough came in the form of blood plasma, which could be dried and stored for longer periods. Plasma helped treat shock, the dangerous drop in blood pressure that followed severe injuries. These advances hinted at a future where wounded soldiers could be stabilized more effectively near the battlefield. Yet the overall structure of the system remained largely unchanged. In 1941, when the United States prepared for war after the attack on Pearl Harbor, the U.S. Army Medical Department was still relatively small compared with the massive forces it would soon be responsible for supporting. Many medical officers had little experience with large-scale combat trauma. Training programs existed, but they were based mostly on lessons from the First World War. And those lessons assumed something that was no longer true. They assumed that battles would move slowly. But the war already raging across Europe suggested something very different. German armies were demonstrating a new method of warfare that relied on speed, coordination, and mechanized power. It was called blitzkrieg. Tanks, motorized infantry, and aircraft moved together in rapid offensives that could break through defensive lines and advance dozens of miles in a matter of days. Front lines no longer stayed still. They moved constantly. And when front lines moved quickly, the carefully organized chain of evacuation that doctors relied upon began to break down. A dressing station that was safely behind the lines one day could suddenly find itself near the front the next. Ambulances struggled to navigate roads crowded with tanks and supply convoys. Surgeons faced waves of casualties arriving faster than the system had ever been designed to handle. By the early years of World War II, it was becoming increasingly clear that modern mechanized war was producing injuries and casualties at a pace that old medical systems could not manage. For the United States, which was preparing to deploy millions of soldiers across multiple continents, the implications were enormous. If nothing changed, thousands of wounded men might die simply because medical care could not reach them fast enough. And the nature of the injuries themselves was also changing. The industrial battlefield of the 1940s was creating wounds unlike anything armies had faced before. Those new kinds of injuries would soon force doctors, surgeons, and military planners to rethink almost every aspect of battlefield medicine. Because the coming war would not only test soldiers on the battlefield, it would test whether medicine itself could keep up with the violence of modern warfare. And as American forces prepared to enter the global conflict, the scale of that challenge was only beginning to become clear. When the United States entered the war after the attack on Pearl Harbor on December 7th, 1941, the scale of the conflict was already unlike anything in modern history. Across Europe, North Africa, and Asia, millions of soldiers were fighting across thousands of miles of battlefield. Entire armies moved with tanks, armored vehicles, aircraft, artillery, and motorized supply columns. War had become faster, louder, and vastly more destructive. For military doctors, this new kind of warfare created a different medical reality. In the First World War, most injuries came from artillery shrapnel and rifle fire. Those wounds were devastating, but they often occurred in relatively predictable patterns along fixed trench lines. World War II shattered that pattern. Now, soldiers could be injured almost anywhere. A convoy moving along a dusty road might suddenly come under attack from dive bombers. A tank crew might survive the initial blast of a hit, only to suffer severe burns from the fire that followed. Infantry advancing across open ground could be struck by mortar shells exploding without warning. Each weapon produced its own kind of trauma. Artillery and mortars scattered metal fragments at high velocity, tearing through flesh and bone. Tank shells caused crushing injuries and devastating burns. Aircraft bombs produced powerful blast waves capable of rupturing lungs and internal organs. Even soldiers who showed no visible wounds sometimes collapsed hours later from internal bleeding or shock. These injuries placed enormous pressure on military medical services. The key problem was time. Medical research had already shown that wounded soldiers had the best chance of survival if they reached surgery quickly. Surgeons needed to clean wounds, remove foreign material, and stop internal bleeding before infection and shock took hold. But modern mechanized warfare often created situations where hundreds or even thousands of casualties appeared within a few hours. The medical system had to respond immediately, and that meant bringing treatment closer to the battlefield than ever before. During the early campaigns of World War II, both Allied and Axis armies began experimenting with new medical ideas. One of the most important developments was the formalization of triage. The concept itself was not new. It had originated during the Napoleonic Wars, when French military surgeon Dominique Jean Larrey organized wounded soldiers based on the urgency of their injuries. But in World War II, triage became far more systematic. At forward aid stations, medics and doctors quickly evaluated each wounded soldier and placed them into categories. Those who needed immediate surgery to survive. Those who could wait for treatment. Those who were lightly wounded and could return to duty. And those whose injuries were too severe to save with the resources available. The decisions were often made in seconds. They were also emotionally difficult. But triage allowed limited medical teams to focus their efforts where they could save the most lives. Another innovation involved blood plasma. Researchers had discovered that plasma, the liquid component of blood, could be dried and stored without refrigeration. When mixed with sterile water, it could quickly restore blood volume in wounded soldiers suffering from shock. Beginning in the early 1940s, large quantities of plasma were shipped to frontline medical units. Medics could administer it in the field, stabilizing wounded soldiers long enough for evacuation. Yet even these advances were only part of the solution. Perhaps the most critical problem remained transportation. In earlier wars, wounded soldiers were often moved by horse-drawn wagons or slow ambulances. But mechanized armies required a faster system. The U.S. Army began expanding its motorized ambulance units, using trucks capable of navigating rough terrain and moving casualties quickly from the front to surgical facilities. In some theaters, particularly in remote areas of the Pacific and North Africa, another new method began to appear: air evacuation. Small transport aircraft were modified to carry stretchers. Pilots flew wounded soldiers from forward airstrips to larger hospitals far behind the front. For the first time in military history, some soldiers could travel hundreds of miles to advance medical care in just a few hours. But the most revolutionary change was still developing inside laboratories and pharmaceutical factories. A substance discovered years earlier by Scottish scientist Alexander Fleming in 1928 was beginning to attract intense interest from Allied researchers. It was a mold-derived compound capable of killing bacteria. Its name was penicillin. For more than a decade, penicillin had remained largely a scientific curiosity because no one knew how to produce it in large quantities. But as the war intensified, the need for an effective antibiotic became impossible to ignore. If scientists could find a way to manufacture penicillin on an industrial scale, it might prevent the infections that had killed so many soldiers in previous wars. By 1943, American and British researchers were racing to solve that problem. At the same time, military planners were rethinking the structure of battlefield hospitals themselves. Instead of waiting for wounded soldiers to travel long distances to large surgical centers, surgeons would move closer to the fighting. Small, mobile surgical teams could set up temporary operating rooms only a few miles behind the front lines. There, they could perform life-saving operations within hours of injury. The idea would soon evolve into a system of forward surgical hospitals capable of moving alongside advancing armies. It was a radical concept, but the scale of the war demanded radical solutions. Across multiple continents, millions of soldiers were fighting in campaigns that stretched from the deserts of North Africa to the jungles of the Pacific and the fields of Europe. And every battle produced the same urgent question. How could medicine move fast enough to save the wounded before it was too late? The answer would emerge through a series of innovations, human, technological, and organizational, that together created a new kind of battlefield healthcare system. Those innovations did not come from a single discovery. They came from many different perspectives. From the medics kneeling beside wounded soldiers under fire. From scientists working in laboratories far from the front. From surgeons operating for hours inside canvas hospitals just miles from the battlefield. Each of these perspectives reveals a different part of the story. And together, they show how the pressures of World War II forced a transformation in military medicine that would shape modern healthcare for generations. On the modern battlefield of World War II, one of the most important figures carried no rifle. The combat medic moved with the infantry, often only yards behind the fighting. His helmet frequently bore a red cross, marking him as medical personnel under the protections of the Geneva Convention. In theory, enemy soldiers were not supposed to target him. In practice, the battlefield rarely respected such distinctions. Medics crawled across open ground under machine gun fire. They moved through shattered buildings, forests, and muddy fields, searching for wounded men calling for help. Many carried only a canvas satchel filled with bandages, sulfa powder, morphine syringes, and plasma packets. The first minutes after an injury were often the most critical. A soldier struck by shrapnel might bleed to death in minutes if the wound was not treated quickly. Medics learned to work rapidly, applying tourniquets, bandaging wounds, and injecting morphine to control pain and shock. Inside the standard U.S. Army first aid packet, soldiers carried bandages meant for self-treatment or to assist their comrades until a medic arrived. But it was the medic who made the difference between chaos and survival. Many wounded soldiers later recalled the moment they saw the medic appear beside them. Sometimes it was only a shadow dropping to the ground beside their stretcher. Sometimes it was the quiet voice of reassurance cutting through the noise of artillery. The medic's job was not to perform surgery. His task was to keep the soldier alive long enough to reach a surgeon. After stabilizing the wounded, stretcher bearers carried them to the nearest battalion aid station. These were often small bunkers, tents, or damaged buildings just behind the front lines. Inside, doctors and medical corpsmen worked quickly to assess injuries. From there, the wounded entered the evacuation chain that carried them deeper into the medical system. But even the most skilled medic faced a constant enemy that could not always be stopped with bandages or morphine. That enemy was infection, and defeating it would require a breakthrough that had been waiting for more than a decade. In 1928, Scottish bacteriologist Alexander Fleming made an accidental discovery inside a laboratory at St. Mary's Hospital in London. He noticed that a mold growing in one of his petri dishes had killed the surrounding bacteria. The mold belonged to the genus Penicillium. The substance it produced became known as penicillin. Fleming recognized its potential as an antibacterial agent, but there was a problem. The compound was extremely difficult to isolate and produce in large quantities. For years, penicillin remained largely an academic curiosity. That changed as World War II intensified. By the early 1940s, teams of British and American scientists began working to transform penicillin from a laboratory discovery into a usable medicine. Researchers at the University of Oxford, including Howard Florey and Ernst Chain, helped demonstrate its effectiveness against bacterial infections. But producing penicillin for an entire army required something unprecedented: industrial-scale fermentation. American pharmaceutical companies, including firms like Pfizer, Merck, and Eli Lilly, began collaborating with government researchers to develop methods for mass production. Large fermentation tanks were built where specially cultivated strains of Penicillium mold could grow under controlled conditions. Scientists also discovered that adding substances like corn steep liquor dramatically increased production yields. The results were extraordinary. By 1943, penicillin supplies were reaching Allied military hospitals. For the first time, doctors could treat bacterial infections in wounded soldiers with a powerful antibiotic. The effect was immediate. Before penicillin, deep wounds often became infected within days. Surgeons had to remove large sections of damaged tissue to prevent the spread of bacteria. Now, infections that once killed thousands could be treated successfully. By the end of the war, the United States was producing enough penicillin to supply Allied forces across multiple theaters. The antibiotic quickly became one of the most important medical tools of the entire conflict. But antibiotics alone could not save the wounded. Survival also depended on how quickly injured soldiers could move through the chain of care. That chain was becoming one of the most carefully organized systems in the war. World War II forced military planners to rethink how wounded soldiers moved from the battlefield to the hospital. The result was a structured evacuation chain designed to move casualties step by step through increasingly advanced levels of care. The first link was the point of injury, where the medics stabilized the wounded soldier. From there, stretcher bearers carried the casualty to the battalion aid station, usually located a short distance behind the front. At this stage, doctors provided emergency treatment and prepared the patient for transport. Next came the field hospital, where surgeons could perform more complex procedures such as wound debridement, removing damaged tissue and foreign material from injuries. Further back were evacuation hospitals, larger medical facilities capable of performing major surgery and providing extended care. Finally, seriously wounded soldiers could be transported across oceans to hospitals in Britain or the United States. The key to the system was speed. Motorized ambulances replaced horse-drawn wagons. In many theaters, wounded soldiers reached surgical care within hours rather than days. Airplanes soon became part of the process as well. In North Africa and the Pacific, transport aircraft, such as the Douglas C-47 Skytram, were modified to carry stretchers and medical attendants. These aircraft could fly wounded soldiers hundreds of miles to safer hospitals. For the first time, large numbers of casualties could be evacuated rapidly across long distances. The system did not eliminate the horrors of war, but it dramatically increased the chances that wounded soldiers would survive. Yet even this carefully designed chain had its limits. In the largest battles of the war, casualties could still overwhelm medical units near the front. To solve that problem, the U.S. Army began experimenting with a new idea: mobile surgical hospitals capable of moving closer to the battlefield itself. Those experiments would soon become another major step in the transformation of military medicine. For most of military history, surgery happened far behind the battlefield. Large hospitals were built where conditions were stable, equipment could be stored, and surgeons could operate with some degree of safety. The wounded were transported there as quickly as possible. But World War II revealed a brutal truth. Sometimes the wounded simply could not survive the journey. Severe bleeding, internal injuries, and shock could kill a soldier within hours. If surgery was delayed too long, even the most skilled doctors could do nothing. The solution was radical. Instead of moving wounded soldiers long distances to surgery, surgery itself would move closer to the front. The U.S. Army began organizing mobile surgical hospitals and forward operating teams that could establish operating rooms only a few miles behind the fighting. These hospitals were designed to move quickly with advancing armies. Their operating rooms were often set up inside large tents or temporary wooden structures. Equipment had to be portable. Generators provided electricity for surgical lamps. Sterilization units worked constantly to keep instruments clean. Inside these improvised operating theaters, surgeons performed procedures that only years earlier would have been considered impossible near the battlefield. They removed shrapnel fragments lodged deep in muscle. They repaired damaged arteries to stop internal bleeding. They amputated limbs destroyed by artillery or crushing injuries. Often the surgeons worked continuously for many hours. During major offensives, surgical teams sometimes operated around the clock, moving from one patient to the next with barely a pause. The goal was not to perform complex long-term procedures. It was to stabilize the wounded, stop the bleeding, clean the wound, and give the patient a chance to survive long enough to reach a larger hospital. In modern trauma medicine, this concept is known as damage control surgery. In World War II, it was still a developing idea, but by bringing surgeons closer to the battlefield, the Army dramatically shortened the time between injury and operation. And in trauma care, time often means the difference between life and death. Yet surgery required something else that was often in short supply on a battlefield: blood. Severe blood loss was one of the leading causes of death among wounded soldiers. Artillery fragments, bullets, and explosions frequently caused internal bleeding or destroyed major blood vessels. Without rapid transfusion, many soldiers died from hemorrhagic shock. Before the Second World War, blood transfusion on the battlefield was extremely difficult. Fresh blood had to be taken from a donor and transferred directly to the patient. This limited the number of transfusions that could be performed and required compatible donors to be present. The war forced scientists and doctors to develop a better system. One of the most influential figures in this effort was Dr. Charles R. Drew, an American physician and medical researcher. During the late 1930s and early 1940s, Drew helped develop improved methods for collecting, storing, and transporting blood plasma. His research made it possible to separate plasma from whole blood and preserve it for longer periods. Plasma could then be shipped overseas in sealed containers. At field hospitals, medical personnel simply mixed the dried plasma with sterile water before administering it to wounded soldiers. Although plasma did not replace red blood cells entirely, it could quickly restore blood volume and stabilize patients suffering from shock. The United States soon organized large-scale blood collection programs, gathering donations from civilians and processing them for military use. Blood banks began supplying plasma and whole blood to hospitals across the war zones. For surgeons working near the front, this supply became essential. A wounded soldier arriving on a stretcher might receive plasma within minutes of entering a field hospital. The transfusion could stabilize blood pressure long enough for surgeons to perform life-saving operations. The blood program became one of the most important logistical achievements of wartime medicine. But while the Allied medical system was evolving rapidly, the same transformation was not always occurring on the opposing side of the battlefield. And comparing those systems reveals another important angle in the story of wartime medicine. Germany and Japan both possessed capable military medical services during World War II. German surgeons, in particular, were highly trained and had strong traditions in surgical research. Early in the war, German medical units often operated efficiently during fast-moving blitzkrieg campaigns. However, the German system faced growing difficulties as the war expanded. On the Eastern Front, for example, distances were enormous. Wounded soldiers sometimes had to travel hundreds of miles across damaged infrastructure before reaching major hospitals. Extreme weather conditions made evacuation even more difficult. In the Pacific Theater, Japanese medical services faced different challenges. Many Japanese units operated on remote islands with limited supply lines. Medical equipment, antibiotics, and blood supplies were often scarce. The Japanese military also emphasized endurance and sacrifice, sometimes placing less priority on the evacuation of wounded soldiers compared to Allied forces. By contrast, the United States and its allies increasingly treated medical survival as a strategic priority. Saving wounded soldiers not only preserved manpower, but also strengthened morale among troops who knew they would receive care if injured. As the war continued, the differences in medical resources and organization became more apparent. American soldiers benefited from growing supplies of penicillin, plasma, and mobile surgical teams. And eventually, these medical innovations would face their most severe test during some of the largest battles of the war. Because no matter how advanced the system became, there would always come a moment when thousands of wounded arrived at once. A moment when every part of the medical chain, from the medic in the field to the surgeon in the operating tent, would be pushed to its limits. One of those moments would arrive in June 1944 on the coast of northern France. There, during one of the largest amphibious invasions in history, the new system of battlefield medicine would be tested under conditions no training exercise could fully prepare for. June 6, 1944, northern France. Just before dawn, the English Channel was crowded with ships. Thousands of landing craft moved slowly toward the coast of Normandy, carrying American, British, and Canadian troops preparing for the largest amphibious invasion in history. For the soldiers inside the boats, the coming battle meant facing German machine guns, artillery, and heavily fortified defenses. For the doctors and medics waiting offshore and along the invasion beaches, it meant something else. A medical crisis unlike anything the war had yet produced. Military planners knew the invasion would generate enormous numbers of casualties within a very short time. Entire battalions might be wounded during the first hours of the assault. If the medical system failed, thousands of those soldiers could die before reaching proper care. But this time, the system waiting behind the assault forces was very different from the one that existed at the beginning of the war. The chain of survival had been carefully organized. Combat medics would move with the first waves of infantry. Battalion aid stations would follow quickly behind the landing beaches. Field hospitals were already preparing to move onto the continent as soon as secure areas could be established. And offshore, hospital ships waited. When the first landing craft struck the beaches of Omaha, Utah, Gold, Juneau, and Sword, the violence was immediate. German artillery shells burst among the landing craft. Machine gun fire swept across the sand. Many soldiers were wounded before they even reached dry ground. On Omaha Beach, where American forces faced some of the strongest defenses, casualties mounted rapidly during the early hours of the invasion. Explosions sent fragments of steel through helmets and packs. Bullets struck men running through the surf. Others were injured by mortar blasts that shattered the sand around them. Combat medics moved forward as soon as the first wounded appeared. They worked in shallow craters, behind steel obstacles, or beside disabled landing craft. Bandages were applied quickly. Tourniquets stopped bleeding limbs. Morphine syringes eased pain and helped prevent shock. When possible, wounded soldiers were dragged or carried to temporary aid stations just behind the beach. From there, evacuation began almost immediately. Landing craft that had delivered troops to the shore were quickly loaded with wounded men and sent back to ships offshore. Naval medical teams received them aboard destroyers and hospital ships equipped with operating rooms. At the same time, engineers and medical units began establishing field hospitals on the beachhead itself. Canvas tents rose quickly behind the dunes. Surgeons unpacked portable instruments and sterilization equipment. Generators hummed as surgical lamps flickered to life. Within hours of the first landings, operations were already underway. The system was not perfect. The intensity of the fighting created confusion. Some wounded soldiers waited longer than doctors hoped. Others had to be treated under extremely difficult conditions as artillery shells continued to fall nearby. But compared with earlier wars, the difference was dramatic. Many soldiers reached surgical care within 2 to 6 hours of being wounded. Penicillin and sulfa drugs were administered to prevent infection. Blood plasma stabilized patients suffering from shock. Inside the operating tents, surgeons worked continuously. Some teams performed dozens of procedures in a single day. They cleaned contaminated wounds, removed metal fragments, and amputated limbs too severely damaged to save. In many cases, those rapid procedures prevented infections that would have killed soldiers in previous wars. Meanwhile, the evacuation system continued to move casualties away from the beaches. Ambulances carried patients to larger field hospitals deeper inside the growing Allied beachhead. From there, transport aircraft and hospital ships moved the most seriously wounded to hospitals in England. The medical chain was functioning under combat conditions for the first time on such a massive scale. And despite the chaos of the invasion, it was working. Yet Normandy was only the beginning. As Allied armies pushed deeper into France and Germany, they would soon encounter battles that lasted for weeks under brutal winter conditions. In those battles, the system of battlefield medicine would face an even greater test, one where cold, exhaustion, and relentless fighting pushed doctors and soldiers alike to their limits. That moment would arrive only months later, in the forests and frozen fields of Belgium and December 16, 1944, the Ardennes forest. Before dawn, the silence of the snow-covered hills in Belgium and Luxembourg shattered under the roar of artillery. Hundreds of German guns opened fire along a 70-mile stretch of the Allied front. Shells exploded across American positions, tearing through forests and villages that only hours earlier had seemed quiet and secure. The offensive would soon become known as the Battle of the Bulge. For American forces, the attack came as a surprise. German armored divisions pushed forward through narrow forest roads, cutting through isolated units and creating confusion across the front. Within hours, thousands of soldiers were engaged in desperate fighting. And with the fighting came a flood of wounded. The conditions were among the worst doctors had faced during the entire war. Temperatures dropped far below freezing. Snow and ice covered roads, slowing ambulance movement. In some areas, advancing German forces temporarily cut off medical evacuation routes. Yet the medical system that had been developed throughout the war now faced its most severe trial. Combat medics moved through forests and frozen fields, searching for wounded men lying in the snow. Frostbite became a serious danger for both patients and rescuers. A wounded soldier left exposed to the cold could die from hypothermia before reaching help. Medics wrapped casualties in blankets, applied bandages with stiffened fingers, and injected morphine to control pain. Whenever possible, they administered plasma to stabilize soldiers suffering from shock. From the battlefield, stretcher teams carried the wounded to aid stations established in farmhouses, barns, and small village buildings. Inside these makeshift shelters, doctors performed rapid triage. Those requiring immediate surgery were rushed toward field hospitals. Despite the chaos of the German offensive, the Allied medical chain continued to function. Motorized ambulances struggled along icy roads, often driving at night without headlights to avoid enemy aircraft. Drivers navigated narrow forest routes while artillery thundered in the distance. In some sectors, evacuation aircraft began flying wounded soldiers out of the combat zone as soon as weather conditions allowed. But perhaps the most critical work took place inside the forward surgical hospitals positioned near the front. These hospitals operated under extremely harsh conditions. Generators struggled in the cold. Surgical teams worked for hours without rest as waves of casualties arrived. In some cases, doctors slept only briefly between operations before returning to the operating tables. Inside the tents and improvised operating rooms, the principles of modern battlefield medicine were fully applied. Surgeons focused on rapid, life-saving procedures. They controlled bleeding, repaired damaged arteries when possible, and removed contaminated tissue from wounds to prevent infection. Penicillin was administered widely to protect patients from bacterial complications. Blood transfusions became routine. By 1944, the Allied medical supply system had matured to the point where whole blood could be delivered regularly to forward hospitals. This allowed surgeons to stabilize patients suffering from severe blood loss more effectively than ever before. The results were remarkable. During earlier wars, many soldiers with similar injuries would have died before reaching advanced care. Now, large numbers survived. Even under the brutal conditions of the Ardennes winter, the evacuation chain continued to move wounded soldiers away from the front. Ambulances transported patients to larger evacuation hospitals located deeper behind the lines. From there, trains and aircraft carried the most serious cases to hospitals in France, Britain, and eventually the United States. The system was not flawless. Some soldiers still died waiting for transport. Others arrived too badly wounded to save. But the overall survival rates demonstrated how dramatically wartime medicine had improved. By the final months of World War II, an American soldier wounded in battle had a far greater chance of survival than a soldier injured in the First World War. The transformation had not come from a single discovery. It had come from the combination of many innovations: trained combat medics, organized triage systems, mobile surgical hospitals, blood transfusion programs, and powerful antibiotics like penicillin. Together, these advances created a new model of battlefield medicine, one capable of responding to the enormous human cost of modern industrial warfare. And when the war finally began to draw toward its end in 1945, the impact of that transformation could be measured not only in military victories, but in the lives that had been saved. Yet the story did not end when the guns fell silent, because the innovations developed during the war would soon begin shaping medical systems far beyond the battlefield. By the time the war in Europe ended in May 1945, the transformation of American battlefield medicine was no longer theoretical. It could be measured. At the beginning of the 20th century, survival for wounded soldiers had been uncertain. During earlier wars, large numbers of casualties died not only from their injuries but from infection, shock, and delays in reaching medical care. World War II changed those numbers dramatically. According to post-war medical analyses conducted by the U.S. Army Medical Department, roughly 3 out of 4 American soldiers wounded in action survived their injuries. This survival rate represented one of the highest ever recorded in a major war up to that time. Several factors contributed to that improvement. The first was speed. The structured evacuation chain meant that many wounded soldiers reached surgical treatment within hours rather than days. Motorized ambulances and organized transport systems allowed casualties to move quickly from aid stations to field hospitals. Air evacuation, still limited but growing during the later years of the war, shortened the journey even further. The second factor was infection control. Before the widespread availability of antibiotics, infection had been one of the greatest threats to wounded soldiers. Deep wounds contaminated by soil, clothing, or metal fragments often became deadly within days. The arrival of penicillin and improved sulfa drugs dramatically reduced those risks. Doctors administered antibiotics almost immediately after injuries occurred. Combined with surgical cleaning of wounds, these drugs prevented many infections that would previously have spread through the body. The third factor was the expansion of blood transfusion programs. By 1944, the Allied medical system was capable of delivering large quantities of plasma and whole blood to hospitals near the front. Surgeons could stabilize patients suffering from severe blood loss before performing major operations. The effect on survival rates was profound. Thousands of soldiers who would have died from hemorrhagic shock in earlier wars now had a chance to recover. Another major contribution came from improvements in surgical techniques. Doctors had learned that rapid treatment of wounds, especially the removal of damaged tissue and foreign material, was essential to preventing infection. The concept of early surgical intervention became standard practice across the Allied medical system. Forward surgical hospitals made that possible. Instead of waiting for patients to reach large hospitals far behind the lines, surgeons operated close to the battlefield itself. These early procedures often meant the difference between life and death. The scale of the medical system itself was also enormous. By the later years of the war, the U.S. Army Medical Department included hundreds of thousands of personnel: doctors, nurses, medics, laboratory technicians, ambulance drivers, and support staff. Field hospitals, evacuation hospitals, and general hospitals formed a vast network stretching from the front lines to medical centers across the Atlantic. Hospital ships crossed the oceans carrying wounded soldiers away from combat zones. Transport aircraft evacuated thousands of patients to safer facilities in Europe and North America. The entire system functioned as a coordinated effort to preserve life amid one of the most destructive conflicts in human history. But the most remarkable consequence of this system was not simply the number of lives saved during the war. It was the knowledge gained. Every operation performed in a field hospital, every transfusion administered in a surgical tent, and every dose of penicillin given to a wounded soldier contributed to a growing body of medical experience. Doctors documented what worked and what did not. They studied the treatment of burns, fractures, blast injuries, and infections. They developed better techniques for stabilizing trauma patients and preventing shock. These lessons would not remain confined to the military. When the war ended, thousands of doctors and surgeons returned home, carrying with them the knowledge gained on the battlefield. And that knowledge would soon begin reshaping medicine far beyond the world of military hospitals. Because the systems developed during the war would become the foundation for something entirely new. A modern approach to trauma care that would eventually influence civilian hospitals, emergency medicine, and disaster response across the world. The innovations in military medicine during World War II did not disappear when the war ended in 1945. Instead, they became the blueprint for modern trauma care worldwide. One of the most immediate influences was in civilian hospitals. Surgeons who had worked in field hospitals and mobile surgical units brought new techniques and protocols home. Wound care, rapid surgical intervention, and blood transfusion practices were quickly adapted to urban and rural hospitals alike. Perhaps the most enduring contribution was the idea of organized, rapid response trauma systems. Before the war, civilian hospitals often lacked coordinated methods for treating mass casualties. Now, lessons learned from the battlefield were applied to peacetime emergencies. Ambulance services began adopting systematic evacuation chains. Triage principles were standardized, and trauma centers emerged to provide specialized, immediate care. Air evacuation, first widely used in World War II to transport critically wounded soldiers, became a foundation for modern medical airlift services. Helicopter evacuation, later seen in the Korean and Vietnam Wars, was conceptually rooted in these early wartime innovations. Another critical legacy was the expansion of blood banking. The mass production techniques developed during the war allowed hospitals everywhere to maintain reserves of plasma and whole blood. Today, the ability to store and distribute blood rapidly owes directly to the systems created under the pressures of global conflict. Medical education also evolved. The U.S. Army's emphasis on trauma care training led to the development of specialized programs in emergency medicine and surgery. Doctors trained in the field returned to teach others, spreading knowledge that had once been confined to the battlefield. Beyond techniques and infrastructure, World War II also changed the culture of medical care. Survival became a strategic priority. The idea that every injured individual could and should be saved when possible informed both military and civilian medicine. Morale, efficiency, and resource allocation were all affected by this shift in thinking. Even international medical practice felt the impact. Allied nations shared research on antibiotics, transfusion methods, and surgical techniques. Penicillin, once difficult to produce, was now available worldwide, reducing infection-related deaths far beyond the battlefield. By the late 1940s, trauma medicine had become an organized, systematic field. Hospitals were no longer passive centers waiting for patients to arrive. They had adopted the military principles of speed, preparation, and specialized care. Emergency medicine as a discipline had roots in the battlefield lessons of 1942 to 1945. The Second World War had forced the United States and its allies to confront a harsh reality. Traditional medical systems could not keep up with modern industrialized warfare. The result was a revolution. Doctors, medics, and researchers transformed not only survival rates on the battlefield, but also the very way medicine would be practiced in the decades to come. The innovations born out of necessity, mobile surgical hospitals, blood programs, rapid evacuation, antibiotics, and structured triage, were no longer experimental. They became standard practice, forming the foundation for all modern trauma care. As the guns fell silent across Europe and the Pacific, the war left behind a legacy of life-saving knowledge. What had been learned in tents and forward surgical units would ripple across generations of healthcare, proving that even amid the destruction of war, human ingenuity could create systems that preserved life. The story of this transformation brings the narrative to its final reflection. The meaning of these innovations not just for soldiers, but for humanity as a whole. War is often remembered for destruction, but sometimes its greatest legacy is the life unexpectedly preserves. The story of World War II battlefield medicine is one of human ingenuity forged under extreme pressure, a stark reminder that necessity drives innovation. The United States entered the conflict with a medical system rooted in the past, designed for slow-moving trenches and small-scale battles. Soldiers arrived wounded faster than medics could reach them. Infections claimed lives as surely as bullets. The industrialized, mechanized nature of modern war threatened to overwhelm every part of the medical chain. Yet, out of necessity, a revolution unfolded. Combat medics moved with the infantry, providing immediate care under fire. Mobile surgical units brought life-saving operations closer to the front. Penicillin, mass-produced for the first time, began defeating infections that had once been fatal. Blood transfusions and structured evacuation chains ensured that soldiers could survive the journey from battlefield to hospital. The impact was profound. Survival rates soared. Thousands of men who would have died in earlier wars returned to their units or went home to civilian life. The lessons learned on the beaches of Normandy, in the frozen forests of the Ardennes, and on islands across the Pacific reshaped the very nature of trauma care. Beyond the battlefield, these innovations rippled across history. Civilian hospitals adopted rapid triage systems. Blood banks became standard, and emergency medical services evolved into the modern frameworks we rely on today. The war had forced medicine to adapt to the pace and brutality of industrial conflict. And in doing so, it created tools and knowledge that continue to save lives decades later. Ultimately, this story is not only about technology or strategy. It is about the value placed on life, even amid devastation. World War II did not simply destroy. It demanded that humanity respond, invent, and preserve. In the chaos of war, the seeds of modern medicine were sown, proving that even in the darkest hours, survival and innovation are inseparable. The battlefield of the 1940s became a classroom, teaching the world lessons in speed, precision, and compassion, lessons that continue to define how we fight for life today.